Hello, everyone, and thanks for joining us. My name is El-Sharif, and I'm a steering committee member at ACE. ACE is a global community of machine learning practitioners and researchers who have gathered around topics in AI research, engineering, and products. We have a repository of YouTube videos that showcase authors presenting their research and practitioners demonstrating the use of emerging machine learning methods and tools. We also host social events where you get a chance to network with fellow community members. We conduct workshops focused on helping participants take machine learning concepts from foundational theory all the way to fully deployed models. We have multiple streams organized around topics, and the presentation today is part of the model interpretability stream. We encourage you all to subscribe to our YouTube channel and check out our website at ai.science. Today, we are hosting Raheel Ahmad and Muddassar Sharif. They are both researchers and co-founders of explainX AI. It is an AI startup that provides a freely available explainable AI platform to explain any black box model. They are both visiting research scholars at NYU Tandem School of Engineering, and they are both working on research to bring interpretability and explainability to current AI models. They both serve as partners of MLtron, a data science consulting firm based on NYC and Shanghai. They will be presenting their ExplainX solution, which is intended to be used by data scientists to understand model behavior, remove biases, and create explanations for business stakeholders. ExplainX Solutions is freely available, and we're going to be getting a hands-on demonstration on how to utilize it and to gain insight into the inner workings of machine learning models. It's a very interesting presentation, and we are looking forward to it. To the audience, please post your questions in the chat, and we will be asking your questions immediately after the presentation. So without further ado, I will now turn over the presentation to Raheel and Muddassar. Please take it away.
Ali, thank you so much for having us. And to all the audience out there, I'm Raheel. And with me is my co-researcher, Muddassar, as well. And we are both co-founders and AI researchers at ExplainX, which is an explainable AI framework for model developers. So let's get right into it. And so we have created ExplainX, which is an end-to-end model interpretability framework for model developers. And we like to call it end-to-end because our ultimate aim is to ensure that even a non-technical user is able to understand the logic behind the predictions these black box machine learning models are creating. Thus, we are creating this end-to-end cycle from model explanation that ultimately leads to model deployment and to actionable decision making. And for us, success is when the business is able to confidently and predictably generate value from their AI initiatives or AI models at scale. And so, this explainX is mainly an open source tool that is model agnostic, and it's more fast and easy to use since it comes with a single line of code that you can deploy that Muddassar will demonstrate more, and has all the famous extensive explainability techniques for you to get started, right? To make explainX extensible, we are focusing on four major aspects. By doing extensive research, we found that these are the four major stages of interpretability. The first aspect is a global level explanation, where we try to explain the model behavior on a global level. The second is the local prediction explanation, which is more about explaining specific instances. And the third part is the feature analysis, analyzing features, how they are contributing to the prediction. And the fourth on the list is the data distribution to identify bias and making sure how our data is distributed among multiple different. And so let's dive in a little bit deeper and see how the architecture is built and how it differs from the other libraries out there. Everything in purple has currently been added. The not in purple is basically still in line, and we are working on implementing it into the library. We believe the combination of these algorithms together help us create an end-to-end interpretability framework that ensures success and true understanding of the model. So just on top, we have attribution-based algorithms like SHAP, blind matching disposal. Then we have example-based algorithms that helps you build example-based reasoning, such as Dash. And then we have feature interaction methods like the partial dependence plot, which is pretty basic. And we have added on top of it a what-if analysis form that provides you with local explanation plus also enables you to sit down with your business manager and try out different scenarios. And then at the end, we have data distributions to look at outliers and identify if there's bias or not. And then on top of it, you get this really cool interactive visualizations that you can actually play around with, and you can actually share them with your business stakeholders. So, in very simple, how can we visualize and explain these complex models? So let's get started with a top level overview of how the explainX library basically works. So this is a basic example of where we are trying to explain the XG boost model on a Hello data set by FICO. Muddassar will be getting more into how the platform itself works. But as you can see, this is the simple line of code that the data scientist has to run, and then at their disposal are all these interpretability techniques that they can use and interpret their machine learning models. As just as a high level view of what is currently present in the library. So I'm not going to be talking in much deeper because Muddassar will be giving us the demo of how the product works. But on a general level, the current features include visualizing attributions of a black box machine learning model. Then you have extract information using insights generator, where we're using natural language to translate the results, the insights from a bar chart into natural text. And then we have slicing into model prediction by using SQL. This is more part of the regional model, understanding regional model behavior. And then you have analyzing feature interactions, checking distributions, simulating model behavior by using what if analysis, and then creating example based reasonings by using prototypes that Muddassar will really dive into in the demo. So we have come quite far, as you saw in our current version. We have all these feature attribution-based methods and example-based algorithms that data scientists will be able to use. And we have also added interactive platform that will help data scientists, interactively debug and understand their machine learning models. In the future pipeline, we are planning on adding more algorithms for such as counterfactuals, adding decision trees for global level explanation, anchors, and by automated bias detection. That has been a core focus of our research. And then we're also planning to scale it for enterprise adoption and real-time monitoring so that data scientists are able to take their machine learning models from research to deployment at a much faster pace. And if you want to try it out, you can actually just go onto the GitHub page. There's a QR code that you can actually scan in the next slide and build use cases. And we just want the community to get as involved as possible. So this was just a basic overview of how ExplainX is basically what it's providing and how it basically works. And now I would like to hand it over to Muddassar so that he can share his screen and take us through the demo of ExplainX library. Muddassar?
Yes, we can see
So
it.
I'll just, there are two main questions that data scientists have to answer. So there are two main questions that data scientists have to answer after building the model. Number one is, what is the overall logic of the model? And number two is this logic reasonable? Can we trust this and use this model into production or not? And to answer these questions, data scientists would ideally like to understand the behavior of the model as a whole, and also the behavior of the model on small set of data. And also, they also have to explain this understanding of the model to domain experts to see if the model is aligned with domain experts' understanding of the world. And it's really, really important to compare this because we want the model to always focus on right variables when making a prediction. And so Explainx allows domain experts and model builders to collaborate and work as a team to understand the logic of the model first, and then decide if this logic is aligned or if it makes sense or not, right? So to use this library, you just have to pip install Explainx, and then you will go into your Jupyter notebooks. You will just with single line import this into your Jupyter notebook. And over here, I have a simple model which is built on FICO loan application data set, where each row is one loan applicant, where they have all these variables. And my Y variable is whether that person will pay back the loan or not. So if y is 0 means a person will pay the loan back, and if y is 1 means a person will default. So another question is to make the model. So over here for the simple use case, I am building random forest, which will just take in the x and y and make the model. And then to run the library, as we mentioned before as well, it's just one line of code where you will give your data, your x data and your y data and your model and the name of the model, and this will give you a link which will help you open up a dashboard on the other screen. So explainX by default will give you three levels of explanations. There is overall or global level explanations. The other one is region level explanations, because the model might behave differently on different subsets of data.
Yeah, Muddassar, I'm sorry. I think there is intermittent.
And
Yeah,
lastly, it gives you a local level explanations. So it will take some time to
yeah.
load
Muddassar, I'm sorry to interrupt, but
global
uh,
level, which is given by default. Just hang on a second.
now while we're waiting, there was a question from the audience. What we really need is a way to explain neural networks, and maybe you can just comment on that, either yourself or Raheel. When we say any model, does that include explanations of neural networks?
Yeah, that's a fair enough question. And yes, there are several techniques that we have, since we are taking neural networks as the prime example of what we have to explain. So neural networks are definitely supported within the library. It's just that we are still optimizing the library for specific frameworks like PyTorch and TensorFlow. So that is going to take a little bit of, it is a little bit complicated to do it, but that is definitely something that we are working on. So simple neural networks that can be generated through sklearn library or something, they're already supported within the library, so people don't really have to worry about that. Other than that, definitely neural networks are something that is the prime example of, because they are the ultimate black boxes. And so those are the things that we have the aim of like ultimately making white boxes as we move forward.
Okay.
Can you guys see my screen?
Yes.
All right. So after we're done model building, so this is the point where we come, which is the dashboard. And now the first part is basically the global level explanation. And at the back end, you basically have feature attributions. Most of the time, it's using the technique called Shapley values to generate these global feature attribution values. So depending on what the size of the data set is, it takes a little bit of time springing up. So as you can see, it's already sprung up, and because we are also dealing with a lot of high level data sets. Yeah, that's working. All right. So on the first level, you have a global feature importance, which is a very basic sort of a graph that everyone kind of looks at. So we have Shapley values at the back of it, and this basically tells you what the top features are, right? But let's go a little bit more further and talk about what the global feature impact is. This feature impact actually tells you that how each variable is impacting the final prediction. It could be a positive impact, it could be a negative impact. So on a global level, this clearly shows you that on average, the variables status of existing checkings account, duration in month, and credit history will increase the probability of achieving outcome zero, in this case, no credit risk, by 4.42%, 2.5%, and 1.5% respectively. And now this is a very interesting insight, because if you're talking to your domain expert, then you can, instead of just showing them this graph and telling them what these impact value means, you can actually tell them how it's going to impact the overall prediction. On the second part, on average, you can also see the top bottom variables that are also impacting negatively. So now you can actually tell them that, the variables of people being liable, years they have spent on their residence, and the personal status and their sex will basically change the probability of achieving outcome zero by negative 0.08%. I know it's a very minor sort of a percentage, but if you think at scale, these minor percentages can become a big. And then you can go into the regional level explanation. And the regional level explanation is very interesting, because now if you can think about this, you can actually say that, all right, so I need to figure out how my model is behaving when the credit amount that I have is greater than, let's say 5,000, and the purpose is greater than 3. So then you just simply execute the query, and then what it's going to take is it's going to take the subset and then calculate the feature attribution values for that specific subset and see how the model was basically behaving on that specific subset of data. And that is extremely important to have, because imagine you have uh, you have you have customers in New York City and you have customers in Los Angeles, right? And now you want to identify how the model has predicted customers that were in New York City and the customers that were in Los Angeles. So now you'll be using this SQL to dig deeper uh, into your model, and now you'll actually see that what is the impact. Now we can actually, this is pretty interesting. Now you can see that, the variables on the top that had the positive and the negative impact, they remain the same, but the percentages have changed. Their impact has changed. And this tells us a lot that, maybe the model there's another variable that might be working for this cluster of uh, customers. So that is a pretty interesting insight. The second part is where we dive into, which is the local explanation part. And the local explanation part is extremely important, because now you have new customers that are coming in, and you want to see how the model is predicting for that specific variable. Now you have this what if analysis form at the left, and then you have these local feature impact graph, which basically tells you what the impact values are for that specific customer. And now we have customer number 1, and we can clearly see that the average probability of predicting 0 is 0.31. And then you get this summary of what that actually means. And now you can actually sit down and say that, all right, so what if the duration in month for that specific customer was, let's say, 10? It was not 9. So you can actually, this is a very interesting tool, because we did a lot of interviews, and we found that, this kind of back and forth interaction between the data scientist and the business domain expert is crucial for them to trust your machine learning models. So now you can actually sit down and you can, just create different values. It's going to call the prediction function and generate these attribution based values. Now, we also found that a lot of the people think in terms of examples. Whenever someone tells us that, why is this happening, we can say that, there were 5 different customers that I dealt with that had very similar profiles. What was similar? They had maybe the same age, or they had maybe the same credit amount. And so we have added this similar profile tab, which is calculating prototypes, identifying prototypes from within the data set that closely resembles to the customer that we are trying to predict. So we have 5 prototypes, which means that we have 5 customers that had similar prediction, but had very similar sort of attributes with the customer that we currently have at hand. And now we can see that, all right, so they had the same credit history. Oh, that is very interesting. They had, this second customer had the same purpose, had the same installment rate, had the same personal status with the customer that we are trying to predict, and they both had kind of the same prediction. So now it actually strengthens our narrative of how the model has come to this decision by choosing examples from within the data to support the reasoning. So this we have found to be a very powerful tool in sitting down with the stakeholder, the business stakeholder, and identifying and convincing them by generating examples from within your data. The third tab that we have is a very simple feature interaction tab. And everyone who has been doing this for a very long time understands that, identifying how each variable is impacting is extremely important. So here we can actually just change to credit amount, and here we can actually change credit amount as well. And we can see that, we can see a trend that, as the value of a certain variable increases, you can actually see that as the value, most of the values are here in this region, but there are definitely certain outliers that are out here. And then we can actually see, all right, so we can actually go back and see, all right, what was the behavior of these outlined uh, customers. And now that is important because we can actually use this data and we can actually go back and see they had a very high credit amount, but this also had a really high credit amount. Why was the prediction zero as opposed to this person who also had a really high credit amount, and he did not have that sort of a risk, or he was approved the loan? So now by using PDP, sometimes you can actually identify trends, but also you can actually look at outliers of how outliers are performing. So this is a very interesting sort of uh, feature that we have that actually helps you identify the marginal effect one or two features have on the predicted outcome. And then everyone is familiar. I hope everyone is familiar with the summary plot. And initially, as data scientists, we do not like this summary plot. But apparently, if you look at the summary plot, this gives you a high-level overview of how your predictions and your impact values are distributed. And the domain experts kind of love it because they're able to see the entire picture, and they're able to see, all right, so my value of credit amount is very nicely distributed. And as the feature value goes up, the impact it has on the prediction also increases. So now you can actually use this data to identify trends by looking at this color, that, as the value of that specific variable increases, the impact it has on the outcome either increases or decreases. And that is an interesting insight for a domain expert to have. And then lastly, we have the distributions. And the distributions, I must say, is kind of like the basic aspect of identifying very easily on a high level how your data is distributed. There might be outliers, there might not be outliers. So by looking at distributions, you can simply, evaluate how your data is distributed for better data preparation, maybe identifying outliers at the top. So something that definitely comes in handy. And lastly, we have a multi-level EDA that is a little bit complicated, but it's more of a business intelligence tool for model development. You can actually choose the size of the bubbles that you want. You can actually choose it with credit amount, and you can drill a much more deeper, and you can actually see that for status of checkings account where it was 3, there's kind of like more less size bubbles, but where the status of checking account was 1, you have high size bubbles. So this means this is a cluster of customers that have asked for a more credit amount. And then you can even add color, and you can say that I need my probability of predicting class 0. What was kind of like that sort of thing. That as the probability goes high of predicting class 0, which is basically getting approved by the loan officer, you can actually see that where the status checking account was, color was yellow, we had more chances of people getting the loan. And now we can actually go back and see what was the patterns within these data sets that basically help us identify these sort of cluster of customers. And all of this is basically true to the model, which means that we're using the model predictions to generate these insights. And that is why it's easy for us to now actually go from the model building part and then use these 4 different aspects or stages of interpretability to create a narrative or a report that we can further share with our business stakeholder, and then can initiate a debate that this is how the model is working, this is how the model behaves in this different subsets of data, and that is why you need to trust the machine learning model. And then, as I said before, the local explanation part is pretty interesting as well, where you sit down and you simulate these different scenarios that, what if my credit amount was in this range? How does that model behave then? So by doing that, you're able to dig deeper into your machine learning model and basically able to make it more of a white box than a black box. Thank you. I hope that was insightful.
Well, thank you, Muddassar, and thank you, Raheel, for that presentation, for sharing your tool with us. I am now going to turn over to the audience question portion of the session. I've received some questions ahead of time, and as well as we're monitoring questions through chat as well. So maybe the first question is, if you can help us clarify the difference between feature impact and feature importance. So if you don't mind sharing back and helping us understand the difference between feature impact and importance, how can, yeah, go ahead.
So feature importance is on a global level. Feature importance just tells you on an average level by taking absolute value of those impact values that these are the top, if these are the top 3 or 4 features that impact the model the most. What is interesting about feature impact is that it goes a little bit deeper and tells you how the feature is impacting the model. Is it positively impacting the model, or is it negatively impacting the model? So by looking at the feature impact values of the global feature impact graph, you can actually see that these are top 3 features, but this doesn't really mean that they are the most important one. The top might feature might be impacting the prediction in a negative way, might be decreasing the probability of achieving certain predictions. So identifying that gives you a much deeper insight into how the model is behaving. So that is why it's important to differentiate between global feature importance and global feature impact.
So like adding one over here, basically the feature importance tells you how important the feature is, right? But that importance can be positive or negative, right? Maybe that feature will always increase your probability, or on average, it will decrease the probability, right? So these are 2 different trends in importance, either positive importance or negative importance. So a feature impact graph is just the add-on of feature importance. It gives you one extra detail. It's positive or not.
Okay, so now the other question here is on what basis was the similarity determined? So you've shown a chart where you've identified these were similar examples. Were they based on similar inputs or similar predictions, or maybe a combination of both? Could you just shed some light onto the basis for similarity? Well,
yeah, so we're using an algorithm that came out in about, I think, 2017 or 18 by the name of Protodash and Protogreedy and Protodash. And so what it does is it basically uses this metric, maximum mean discrepancy, which is basically the median differences between the averages of different features, and it tries to minimize that. So the closest that that MDD is to another feature within your data set, the more similar it is to that specific sort of instance. So if people want to learn more about the basics of the algorithm, I can actually share the link with you of the paper that we used to build the theoretical framework behind this, and then you can actually share with your viewers so they can actually have a much better read, because that is a completely very highly mathematically dense sort of a paper.
Okay. Now the other question here is obviously the example that you presented, and the is a classification-based example. So
Yeah.
I'm assuming that that's what your solution is focused on, is classification-based problems and not regression-based problems. Is that a correct statement?
I mean, no. So we are focusing on regression-based problems as well. But our focus or the use cases that we have done so far within the industry have been focused more on the classification part. So we definitely support regression-based models as well, and that is not a big deal. That also works. With the current open source platform, you'll get all these similar analysis into the model behavior for the regression as well. But since our industry expertise has been in deploying and scaling these classification models, so we try to remain ourselves into that realm.
Okay. Now, what we saw here when you were focusing on a region and you were essentially running your filters. You're doing a select statement post classification. And I just want to clarify, you're not changing the classifier in any way. You're just filtering the data set, and you're basically, how did the classifier behave in that particular region of the input data. Is that correct?
Yeah, exactly. So there are 2 ways to think about this, right? So you can either filter, or you can filter the data set and run the model again to do it. So running the model, we found that was not feasible when this is in production, because you can't just take the data set and run it again. So instead, you just run on the explainability technique, and you try to find how the model behaved to that predictions of that specific region. So it's correct. By using SQL, you're just slicing and dicing it down.
Okay. Now, are you? I mean, you've identified you're supporting SHAP and Lime. Are you deciding which explainer is going to
Right.
be used, or are we basically setting that up upfront? So, and if you're
I
deciding,
mean that's a very fair question, and we have used multiple different techniques to like experiment with it. The biggest feedback that if we try to automate this, then the problem becomes that how the users will need to understand how IG or SHAP or Lime when do they work the best. So we just found the best way with recent interviews that it's much better to just give them the option. So in the future version, in the future releases, there's going to be a small little tab that will help you choose the kind of the explanation techniques that you can actually use. Currently, it's kind of automated, but it just creates more trust issues than it is supposed to, like, because the problem is that we found was, there's no way to evaluate these interpretability techniques, how accurate they are. You can use fidelity as a metric, and we're definitely using that at the backend, but still it needs to be in the control of the data scientist to choose if they want to go with Lime, IG, or SHAP based on the context. And I think that is also useful because it just allows people to dig in deeper into the logic of these techniques, not just blindly follow what the techniques are. So I think that would be the best path that we're going to take.
okay, fair enough. And are you reporting maybe the confidence in the prediction or the confidence in the explanation somehow, or are you basically making a best effort in leading at that?
I mean, there is a metric that we're optimizing at the backend, which is fidelity, which basically tells you how loyal the explanation is to the specific model. But that isn't on the front end. And in the future, if someone asks us, how much can we trust these different sort of explanations, we definitely planning on like, just making it coming onto the front end. That's for this specific customer, the explanation technique is about 85% sure, for example. So we have experimented with it, and it has worked pretty well. But we are still like making sure that in different scenarios it gives us the dividends that.
So like adding on over here, like we have right now like probability of getting 0 or 1 right now. So like for example, like how sure the model is when giving 0, we have that extra feature right now, probability, and that is in the view data tab right now in the interface.
Yeah.
Okay. So we have another audience submitted question here is, isn't it better to build explainable models instead of having to explain them post hoc? So go
I love
ahead.
that. I actually love that question. It's actually it's a very interesting question, and I personally do believe that people should start building interpretable. I don't know if Muddassar will agree with me or not. I do have that inclination that there's a lot of debate around the black box and stuff. So why don't we just? It's not. Firstly, it's not that easy. Firstly, it's not that easy to build really highly accurate algorithms and make them interpretable, because the idea that they're complex and they're not understandable is what makes them really valuable for us, because they're taking so much data and they're really complicated. And so I like to think of it as a kind of like a microwave sort of example, because our target audience is more people who are actually just using these sort of microwaves and not manufacturing these microwaves. And these microwaves are working perfectly fine, as long as they're working perfectly fine. So, I mean, we can build interpretable models, but that would be extremely complicated. And I see that happening 5 years down the line. But people who are currently using it, they just need the results rather than more on the interpretability part, because the techniques that we have, they're well vetted. People are using it. They have a proven track record. They work. Now the idea is, how do we explain how they work to a business user or a person who doesn't really understand them? That is something that we're focusing.
Yeah, like adding on over here, like we have right now some white box models, but they never perform really well into production right now. So there's no point of going after that right now. Maybe like in the future we'll have some models, perfectly good models, which are white box models, which are really good and explains itself automatically. Maybe in the future, but right now, like given that the companies who are investing in the AI wants to have some value out of it, they want models to work in production. So black box are the go-to option right now for that.
Okay. So maybe a question on in terms of just you've been talking to customers and talking to partners to put this together, the prototype. What are the? Can you share with us any interesting use case where they're potentially putting your solution to work here, or are you primarily right now focused on the development end?
I mean, that's an interesting question. Yes, we are focusing because since we are from New York University provides you with an extremely good financial services access as well as a healthcare sort of like an angle. So these are the two places that we are focusing on or working with companies within that sector to implement these use cases. Loan application is a pretty simple one because credit is huge in New York City anyway, so everyone has those sort of algorithms that they're running on.
Sure.
The second part is the healthcare part where we're working with a couple of people from the National Cancer Institute, and then we are trying to figure out how to use those, how to explain those deep learning models. But there's another niche that we are very much working in is hiring, and because now hiring is being automated and the resumes are being read by for personality testing and everything. So they have these really complicated NLP based black box machine learning models. So how do you explain the result of the black box machine learning model for each candidate is also something that we're working on. So these are the three domains that we've chosen for ourselves, and it was not our choice to choose it. They basically chose us, I guess, but that is how we ended up with these three domains.
So and maybe a question about the overarching value here. I mean, you're putting together a collection of tools. So a developer could go ahead and run Lime, run Shap, and
Right.
generate their own visualizations on their own.
Yeah.
Can you maybe just highlight the value that you believe that someone would get by using your solution and putting all of these tools under one roof?
So I think there are two things that we are trying to achieve here. One is the democratization of explainable AI, because we still believe that if you look at the industry, not the academia is way ahead. If you look at the industry, not the big companies, the smaller, the people who are starting to use it, they're still very far behind. And they still don't really understand the technicalities because it's a little bit complicated. So we really want explainable AI to go into the hands of these people that don't really have that sort of software engineering sort of background, and they can customize it, customize these frameworks according to their different models. So that is a difficult part. So firstly, we're democratizing it, and secondly, we're saving time. And time is a commodity, and we want to help the data scientists go from their raw data to model building to production without having to spend a lot of time customizing these tools and everything. So by utilizing this and making these frameworks work for all will basically help us speed up that process that will help companies take their machine learning models from research to production faster, and that is what we want.
Okay.
Like one more point over here is, for example, like we have like SHAP, Lime, IG, counterfactuals, anchors, and prototypes. But like, how do we use these tools to, in the end, get some insights which might help us improve the model? That is one aspect that is right now missing. Like people don't know how to use these tools right now. So building the entire narrative around like how do we use these tools in what steps to find what, and how do you use that insights to improve the model, that is also the part where we want to innovate as well. For example, we found that it's really important to add some natural language with Chap, because it will make Chap easier to understand, right? And the same goes also for, like, for example, like how do we use the prototypes with counterfactuals and use the combo of these two to find rows which are biased, right? So like how do we use these to find insights which might help improve the model as the whole afterwards? That is also one part we want to focus on.
Okay, thank you very much. Now, I am just looking at, it looks like that is the set of questions we have today. So before we wrap up, are there any final thoughts that you would like to share with us?
Yeah, I would love to invite people to use ExplainX, build use cases, join our community. We are also on Slack, and we have these discussions with really great people on Slack. So join us and give us feedback and help us democratize explainable AI. Generate trust in these AI black box machine learning models that are affecting our lives every day.
Yeah, it's like moving back forward right now, for example, like it's really, really important to make sure that the AI we use right now is safe and transparent, right? And that is why XAI is really going to be huge in the future, because we want AI to be safe, AI to do good and not do harm to us right now. And the only way right now to ensure that is if we have something in place which can help us explain why the AI is giving something. So that's rationale and motivation behind why we are working right now on this library, right? And hopefully we can help people like in that as well, like make AI safe.
Okay. Well, with that, I thank Raheel and Muddassar for their great presentation, and I thank all those who joined us online. We have seen a demonstration of the ExplainX solution that is freely available for download. To see more free content like this, please visit our website at ai.science and log in to access slides from this presentation. And also be sure to subscribe to our YouTube channel, ML Papers Explain, to get notified about all the live sessions and other free content we publish. This concludes our events. Thank you for watching.
Thank you.